Okay, I'm also going to jump ahead a little bit just because pretty quickly we're going to hop over to, kind of code. And so I figure one of the things that I can kind of have you guys do in the background is if you want to run your environment locally, I would recommend installing Anaconda. It's this just great Python data science package. It has everything conceivably that you would need, all of which just kind of up to date. No need to worry about like versioning, no need to worry about control, everything like that. Everything is just all together, nice, easy to use, intuitive thing. So if while we're kind of doing some preliminary discussions, if you want to just kind of get that up and loaded right now, it'll just kind of make things a little easier for you. Relatedly, I assume you all immediately, of course, jumped onto CCLE and downloaded the assignment last night, of course. But in the event that maybe some of you haven't, if you want to jump onto CCLE and download that, you can kind of get that pulled up because we're going to start running through that today in course. So again, just in the background, if you want to work through that, we can do so. Let me see if there's anything else. So again, here's going to be the website, the section website. The URL is in the chat as well as on the screen. And then every week, oh, that's not fixed. Okay. Lecture note, session recordings will be there. So I guess any kind of logistics questions really briefly before we dive into some stuff. Oh, here, let me just post these notes again. All right, cool. So let me start by presenting. So let's talk. I want to talk a little bit specifically about this discussion, and we're going to kind of start in a weird space. And let's just face it, it's kind of a weird time, and let's steer into that skid. It's not a particularly, I don't know about anybody who's having a particularly good time right now, and I count myself among them. Oh, is the Piazza link not working? Let me know if the Piazza link's busted. I'll try to fix that.
Sorry, I don't know if it's on my end, but I got put in like engineering or English 110. I don't.
Oh, word? I don't even know how I would have had an English 110. Like, that's funky. Okay, yeah, let me know if anyone else is having troubles with that. Although we could totally hijack the English 110 Piazza, which would be hilarious. But it doesn't direct you to a class. Okay, I'm going to need to figure that out. If I don't figure that out now, I'll just send out an announcement with the appropriate links. So yeah, if Piazza's not working, that's on me. I'm going to have to figure that out. But okay, yeah, I mean, just like getting into this, it's not a particularly good time. Let's just be honest. UCLA is hard enough as is. The quarter system is absolutely brutal and merciless, and we are given like zero break. And moving it online has just kind of eroded everything that made the college experience fun. Access to friends, Westwood, Fat Sal's, campus, food courts, like everything that was like great and redeeming about the college experience has kind of been taken away with you. And the only things that are left are deadlines and projects and exams and lectures. And that is brutal and immiserating. And, let's just kind of acknowledge that and say, look, we're not going to solve it. We're not going to kind of make it better, but maybe we can kind of do our part in our own little corner of UCLA to kind of make the experience a little bit better, a little bit more awesome for all of us. So I wanted to just take like a few minutes to just talk about maybe a few things that we can do to kind of help with that. We had sort of announced some of these in lecture, so but I did kind of want to elaborate on them. The first is the class directory. And so this is just kind of an easy passive way for you to meet other students in the class. This will be a sort of consistent theme of mine. I mean, it's kind of unfortunate that literally you are in a cohort with some of the best and most brilliant people possibly even in the world, and you're all just kind of black Zoom boxes, which is really, really unfortunate. And if there's anything we can do to kind of help break that down a little bit and give you a chance to kind of meet one another, interact, mingle, we want to do so. And so to that end, the first thing that we talked about doing is we're going to send out this weekend a link to a class directory. And very simply, it'll be a chance for anyone who's kind of open to meeting others from the class or making new friends, just kind of a way to sort of put yourself out there, and a chance to kind of more organically meet people for reasons other than, hey, I need help on project one. Can you help me with that? In a similar vein, we're going to do something called the Secret Bruin program. And just quickly, was anybody here in CS180 last quarter? Did anyone here do the Secret Santa thing last quarter? Okay, cool. Oh yeah, Sumya, yeah. Oh, awesome. How was it? Was it just like awful, terrible, or was like that an okay experience for you?
It was fun.
Okay, awesome. Well, I'm thrilled to hear that. So for those of you who don't know, sort of a Secret Santa program, the idea is we try to kind of anonymously assign classmates to one another, and then your idea is to try and do a little research about them, figure out the kind of things that they're into and that they like, and then just try to put together something nice for them. And again, it's digital only because we want to make sure that people from around the world can trivially participate, and it's non-monetary. We don't want anyone spending money on the program. But okay, I said gifts to be delivered finals week because I just copied over from last quarter, but it's one of, I think, the big downsides we did, and I don't know that people from 180 who could talk about this, we did this around the end of the quarter, which sucked both because it coincided with finals week and everyone was stressed out about that. But it also was a bit of kind of a missed opportunity because, all the networks that you made sort of came right at the end of class. And that was kind of a missed opportunity, again, to meet people. So we're going to do this time, beginning of the quarter, hopefully when the workload is not yet overwhelming. And again, hopefully, at least for a subset of you, it can kind of be a catalyst that will allow you to again, meet people that can be at the very least study partners, project partners, and so on and so forth. So you're going to get an email about that this weekend as well. I don't necessarily want to spend too much time on that in discussion section, but let me just pause there and see if anyone has some questions on that. Okay, cool. All right, so I also want to talk about these discussion sections. I've been thinking a lot about what we can do to make these fun, and I'm just going to throw some stuff out there. This is totally happening. We're doing this. Buckle your seatbelts, folks. First things first, there will be themed weeks. Just so you're aware, we are going to totally do a pajama party discussion section. I'm also going to insist on doing a black tie discussion section where, we are going to get all dolled up and we're going to show up not wearing hoodies. We're going to do that. The one thing I am vetoing is the sing-along discussion. My 1 quarter of guitar that I took does not adequately equip me to do a sing-along discussion. But if you have any other ideas for kind of themed weeks that we can do, we're doing this, man. This is happening. The other thing that we're going to be doing in this discussion is I'm going to try to host some contests and just kind of start getting those things doing. We are going to do a costume contest at least 1 week, and specifically for next week, I'm going to officially host a best Zoom background discussion. So your mission for the next week, should you choose to accept, is to find the best, most hilarious Zoom background, bring that to discussion, and then we're going to do this Cards Against Humanity style. The people you have to impress are your peers. This is going to be voted. This is going to be democratic. No vote fixing here. No fake news here. Y'all got to win the votes of your peers, and there will be prizes. So start thinking it now, because this is for next week. So yeah, so that's happening. And again, if you guys have any other thoughts of like fun things that we can do, fun sort of, again, to just themed weeks, let's do that. The other thing that I did during last session that I thought was helpful, and I'm going to try to do it this session as well, is breakout sessions, which I know are just terrible and the bane of your existence, and just miserable. But I do also think it's one of kind of the few chances that you all have to just kind of organically interact with one another. And, you know, again, that theme I'm going to beat to death, just a chance for you all to kind of interact with each other. What I think I'm going to try to do this quarter, that a little bit different than what I did last quarter, is I'm going to reserve this for like the end of discussion. So we're going to have like set material we'll do probably for the first 90 minutes or so. And then for like the last 20 minutes or so, I'm going to kind of leave it for a breakout session. And I'm going to kind of give you some topics if you want to work through it. But the main idea is just to kind of give you guys a chance to, you know, just chill out and not have sort of a firm set agenda. No, oh, 2 minutes, discuss this question, I'm pulling you back nonsense. And, you know, again, if people want to attend, great. If you just kind of want to drop off at that point, great, because we'll have sort of covered the material that we're going to be covering that day. And again, just try to give you that chance. Couple other quick section notes. A request for you guys. Bring your pets to class, please. My God, if you have a cute little furry thing at home, share the love. Bring it, turn that webcam on, let the rest of us bask in that glory. You know, we could all use some therapy animals in our lives. So do bring that love and share that. I am all for that. And talking about little furry friends, you will probably come to know soon enough, I have my own version of a little furry friend who is currently sleeping about 10 feet away from me. And the joy of being a young parent in COVID times without access to daycares or babysitters or anything like that, inevitably, you all will be seeing a fair bit of her. She will be making guest appearances in office hours for sure, possibly even discussions from time to time. And she will be the frequent focus of memes as well. Okay, last thing, I swear to God, I'm almost done. I feel like there's more like background here for this stupid discussion that like most courses have. This is ridiculous. I'm so high maintenance. In case you haven't noticed, memes are basically my sort of way of coping with 2020. And I want to crowdsource my memification. So every week, send me your best memes. There will be we were going to officially create our own little meme bank, and the best ones will get immortalized for all time. So shoot me those memes. Don't let me do all the work harvesting these things. I will gratefully accept everything. So let me pause there. And let me kind of turn that over and ask you guys a little bit of things, because we have a limited amount of time, and like all these quarter things, it's like this fire hose of information that gets dumped at you. And I kind of want to get a sense from you all in terms of how best you'd like to structure the content in this course. And there's several ways in which we can kind of do this. The one is essentially we come in with almost no agenda, and I just kind of throw it over to you and say like, hey, what do you guys want to discuss today? The other approach, and this is generally the approach that I've taken in previous courses, has been more of like a lecture format, just to try and kind of flesh out maybe some of the things that are covered in lecture, some of the things in the projects that aren't necessarily covered as well. We can kind of do as well. Code reviews, you know, again, just kind of just going through examples, data science projects, things like that. Some kind of hybrid. Just, you know, again, you don't necessarily have to answer all of that now, but I do kind of want to hear that feedback from you all in terms of how to structure these, in terms of the kind of content that you want. In addition, you know, again, any sort of topics that you want to cover, I will try to send out a weekly email in advance where okay, so I'm here in one lecture code review. That's kind of what I'm leaning towards right now. Some prepared material, just because if nothing else, it's a good resource for you all to have when you're prepping for the exam and everything, but then also working through some code. I think that kind of hybrid thing is going to be the approach we're going to take. And then, but again, let me know. And then relatedly, like in previous quarters, is there anything that instructors or TAs have done that was particularly helpful, or that that I could kind of incorporate into this, or that the professor could incorporate into this? We really want to hear back from you. We really want this to be as positive an experience as possible. And so if you can kind of just think about anything, again, doesn't have to be right now. I don't want to put you all on the spot, but like throughout the course, if you think about something, just let me know. Okay, so I'm gonna pause there, take a breath, drink more of my caffeine, and see if y'all have anything to say on that. All right, cool. So, a little bit, sort of a little bit brief notion. I know this was sort of mentioned in the course itself, but just to kind of, I guess, set expectations for this. This course is designed to be, it's enough to kind of make you dangerous when it comes to data science. We don't assume you come into this with any background. We don't assume you've taken a machine learning course. We don't assume you've taken any kind of data analytics courses before. We're sort of assuming you're walking in as a bit of a blank slate. So I know that's going to kind of meet you all at different points. Like some of you already taken like 146 or some other things. Others haven't. But hopefully no matter where you're at in that, there's a lot that you can get out of this. Our goal by the end of this course is that you feel comfortable enough with data science that you can, again, that be dangerous. You're by no means going to be a subject matter expert, but you are going to be in a position where, let's say you're interviewing for a job, let's say you're interviewing for something as data science roles, you will be comfortable enough to say, yes, I'm qualified to do that work. I'm qualified. I know how to answer those questions. I know that space, even if I don't necessarily have particular expertise, I know how. I'm far enough along that I know how to get it. In kind of a similar vein, we've tried to make the effort to kind of right size the homeworks and the assignments. We really don't want this to be, I mean, you can't avoid a certain degree of workload, but we don't want this to be overwhelming. So, hopefully it's been right sized. If it's not, if you feel like at some point you're just kind of feeling that, I know the professor and all the TAs were really sort of want to ensure that this is kind of right sized. And if at any point you're feeling not that way, we should definitely, provide us that feedback up front. The other thing, just to kind of note, and this was sort of emphasized before, was we're deliberately front loading the course load. And so, yeah, dropping project one in week one is super party foul. And I recognize that. But the whole idea there is we want you to be completely done with all the material for the course by week 10. And just with the idea that you are then sort of freed up to focus on finals and final projects and other things with your other courses. And this will be one thing that'll kind of be off your plate. It does mean that there's a little bit of a front loading, but again, hopefully that pays dividends down the road. So that's, again, just kind of at a high level, what the goals are for this course, what we're hoping you sort of walk out of this course with. Oh, geez. Okay. Yeah, this is what happens when you do the slides at 2 a.m. last night. Okay. Development environment. So I think this is the point of the discussion where I kind of want to get into the weeds in terms of actually getting you started, getting you equipped to start working on project one. So all that was by way of introduction. So let me kind of pause there and see if there are any questions before we dive into the weeds. Okay. Cool. So hopefully while I've been blabbing in the background, you have been able to get work on downloading your local thing. Now, I will note that you do have some options with this. If you want to run your notebooks locally, which I do recommend in general, you know, the data sets that we're going to be working with in this course are not particularly large. So I don't anticipate, you know, again, it all depends on your individual machine, but generally speaking, you should have no problem running them locally. Having said that, there are resources and environments available to you. Google, for instance, has a service called Colab, which is essentially sort of a cloud-based data science computing platform where you just can upload notebooks like the one we're going to work with and just kind of run off their cloud environment, and you don't have to have anything installed locally. In a similar vein, I think AWS also has something analogous to that. So you have options in terms of, you know, how to run your environment. And if you know, certainly if you have trouble getting it working, if you're having issues, that's what the TAs are here for. But I would definitely recommend at least trying to get it working locally, and then if not, you know, defaulting back to a online, one of the online based ones. Your actual assignments will be handled on what's known as a Jupyter notebook. And just a quick sense from y'all, has anybody worked with Jupyter notebooks before? Is that a platform that you guys are familiar with, or is this kind of just completely new to you? Okay, yes, yeah, Loki, yes, yes. Okay, yeah, oh, okay, one new, no, new, a little bit new. Okay, okay, cool. So I'm seeing a bit of a split here. I find these to be like amazing, and once you kind of dive in and start using them, I think you'll sort of feel the same way. They're a little bit counterintuitive when you get started, and can be a little bit, and there are some like tricks and quirks to it. So I would definitely recommend, so let's go through that kind of briefly so you understand a little bit better how to kind of run it. The first thing to note is that Jupyter Notebooks, they run off your browser. So once you've installed Anaconda, if you just directly in terminal, if you just enter in Jupyter Notebook, it will launch this this GUI right here on the right, and you know, just a sort of a standard file navigation system that you can kind of navigate to. And again, all the work is done directly in browser. So the way sort of Jupyter notebooks work is that the notebook itself is divided into these individual cell-based code blocks where you input the sort of the various components of your program. These cells are run individually. So, you know, unlike if you worked on Python in the past and you've sort of compiled it and you've had to kind of run your .py file from your terminal, for this one, you don't have to run your entire program, which, as you will see, is incredibly helpful. You can run your individual code box individually, but the key important thing here is that your program ultimately is global. So for instance, if you set up a variable locally in one of your cell blocks, you can then reference it downstream in a different cell block. And then inputs and outputs are directly displayed right there on the notebook. So, you know, in that example right there, I load a data set. In this case, it's housing. And then I call the head function, which just kind of provides a nice summary of the thing, and it outputs directly into your notebook. And so you'll see things like graphics, things like charts, tables, results, all of that just outputs directly there, which again is really, really useful. You don't have to jump between your coding environment and, you know, your output environment. It's just a really nice intuitive workflow from that space. The other thing that's notable is that Jupyter Notebooks support a variety of different types of inputs. So, you know, in addition to having sort of code, you can also just do plain text, titles, you can embed images. So it's just, again, it's a really nice sort of hybrid of development environment and then also presentation environment. a few things to note, and again, this is kind of before we dive into the program itself. Because the program is global, but your code blocks are executed locally, you can introduce downstream errors and those will go unnoticed. And the simple reason for that is that once a code block cell is run, the output is static and it will not update until it's run again. So going back to this environment here for this, for my little head function that I called, if I go back and I change, let's say if I change my path for housing, or if I change, whatever thing, that cell block is effectively broken. But I have not, but until I rerun that thing, it's not going to necessarily show up as an error. And so that's something to kind of be aware of as you're working through this. Like you may inadvertently introduce errors as you're trying to debug things and not kind of be aware that that's happening until you go back and you're like, oh, nuts, I broke all this code just because I changed something upstream. So one of the, so just kind of be aware of that. And the things that I would recommend to sort of deal with that is checkpoint your code often. So Jupyter Notebooks, and again, I'll show you that functionality, but just up in the file screen here, they do have the ability to kind of save and checkpoint. So do take advantage of that. Obviously, if you're working off GitHub, push your edits, like save your work just to make sure that you can always kind of revert back if necessary. And then the other thing is it's a good example. And here, again, I'll show you this. You have the kernel for it. It's not a bad idea just from time to time, just to kind of restart the kernel and just rerun from the start, just to make sure that everything is functioning properly. So I don't know if everybody has gotten their thing up and running, but in case they haven't, let me stop sharing here, and I'm gonna share on this screen. Okay, so this is project 1 right here. So hopefully you all have seen, this. Hopefully you all have been able to download this. And again, this is right here. If I just click on it, it opens the cell itself. This is a markdown cell. So it's just a plain text thing. I just hit run and it just compiles it to that. And again, there's a lot of formatting you can do. You want to embed images, it allows that. You want to include URLs for whatever reason, it allows you to do that. It's super, super nice. In terms of, so this is some of the functions I mentioned, save, make a copy, save and checkpoint, revert to checkpoints, all very useful as you're working through this. And then, allows you to sort of run, halt if you need to, if your code block gets stuck. Your all kernel, you can kind of interrupt, restart and clear your output, restart and run all, reconnect, shut down. It sort of gives you the ability to do all of that. Then if you want to sort of embed new code blocks, is very easy to do so. You just hit the plus sign here, and that creates a new cell block for you. It defaults to code, but again, if I want to do something else, I can just shift it there. So let's say, X 12. So let me just run that very simply, and then let me input a new thing. A very basic level, run that. And you see, it just outputs to 16. And then, again, the key thing I want to emphasize here is if I change this, I've now updated X, but this output hasn't changed until I run it again, and then it outputs. And that, again, is that critical thing to remember when you're working through this, is that it's very easy as you're going through and kind of working through the code to make these changes and forget that you have these downstream dependencies. And then because the output looks fine, right? You're not returning any errors, you're not returning any issues until you kind of just run it, and then you realize, oh, okay, crap, I have all of these issues. So let me pause here before we kind of get into this. Any questions specifically on Jupyter Notebooks? Any questions on this environment, working through it? Oh yeah, and then if I want to just cut cells, very easy for me just to cut them, you can copy, you can paste cells, which again is very useful. Like if you have, like for instance, for this project, there's a lot of sample code here that we have that you'll probably want to use. It's very easy just to like copy it, paste it below, and then try to like modify it. Oftentimes when I'm working through something, that's exactly what I'll do. I'll like copy a cell that I know is kind of working. I'll play around with it, try to get like the new version to work properly. And then if that works, I'll sort of clean up my notebook in the end. Okay, so let me just kind of pause there and see if everyone has questions specifically on that. Okay, and then, and again, one of the things like I love is just how great and dynamic the outputs are. So again, this was that head function I was showing before. You call all these things, you can sort of get some nice outputs. You can also get graphical outputs directly on the terminal itself. So you can kind of track all of these things. So super, super useful, super intuitive, just a really great environment to work in. Okay, so any questions specifically on Jupyter Notebook? And just out of curiosity, has anyone here not been able to kind of in the background get on Anaconda running, launch a Jupyter Notebook? Like, has anyone had issues doing that?
I had trouble navigating files in Jupyter.
Loading files into Jupyter?
Navigating directories and all that.
Okay, so you're talking about like it from here, from when you first launched?
Yes, I think I figured it out though. You have to launch it from the root that contains that.
Yeah, so there are sort of several ways to do it. If you just launch from root, it'll just launch here, which is what I typically do. If you in terminal navigate to the directory your files are in and you launch Jupyter Notebook there, it will default to those files as well, to that directory. So either way will work in terms of navigation, but generally I find it just really easy just to kind of do, just to be able to navigate this way and so on. Anyone else having any issues getting up and running with this? Okay, cool. So the rest of it, I think for the rest of this section, we'll talk a little bit about Python itself. We'll walk through the project itself, sort of talk through what we're doing at each step, talk through some of the examples, so on and so forth, if that sounds good to you all. The first thing that I'm going to do is I'm going to restart and run all, just because in case I do want to kind of manipulate it. So you'll see here, just when you see something is queued, it'll have that star sign there. So that shows that it's being run. Okay, so you can see like this here thing is actively being run right now. Okay, that outputs. All these things have output. All these things are outputting. Okay, perfect. Okay, so everything is output. Thankfully, I haven't broken anything in the meantime. Also, just a quick sort of sense from the class. Has anyone here not used Python before? Like, is everybody here at least somewhat familiar and comfortable with it as a language? Okay. All right, cool. Never used it, but you are auditing. Okay, cool. Okay, so as you know, Python relies very heavily on third-party libraries. So as a precursor to pretty much every Python-related exercise that you will use, particularly in the data science space, you're going to sort of import all of your various coding libraries that you're going to use. So what you're going to see here, your setup is always going to be some kind of form of importing things here. We also have, just in case you want this, I don't think we even need this, just a nice sort of, just a nice thing to sort of generate and to export your images so that they're not just limited on your notebook itself, but it'll actually output to your image folder. In case you need that, I don't know that you need it, but it's just sort of a nice script that we have there for doing that. Let's kind of start at a high level. We're going to walk through kind of each of the steps of what you're going to do, and then we'll start getting into the weeds for the rest of this course. Does the version of Python matter? So it doesn't matter, and this is actually an important thing that I should mention in terms of the notes. You will not, so in terms of your submission, and I will get to it in a little bit, but your submission for this will be a PDF of this notebook. So you have the ability here to download as PDF. And so you will literally submit a PDF file of this. And that's important because ultimately it doesn't, we're not going to be running any code checks on this. We're not going to be plugging this in, running this environment. So if you're comfortable for whatever reason with Python 2.7 or whatever, you can do it. I would advise against it just because it makes it a little harder for your peers and the TAs to kind of help you debug stuff. But ultimately, whatever environment or thing that you're comfortable with using, you can use. And in a similar vein, we provide a lot of sample code here to get you started. You don't have to use any of that code. There's a ton of third-party libraries out there. If you want to go another way with it, if you find, if you go on Stack Overflow and you find like a different way of implementing it and it works, that's fine. We are just going to be looking at your outputs. So, and then do I have on here I don't know if I have the directory here. Oh, okay, cool. So let me navigate down to this. So we'll hop back over to the notebook in a little bit. I'll just kind of run through some of these slides that just sort of overview the project one. So again, the assumption is you've never done a data science project like this before. Our goal here is to be able to have you dive right in and be able to actually do an end-to-end project. And in order to kind of empower you to do so, we provide you with a detailed example walkthrough. And that's what we're going to sort of start going through in this class is in this discussion section, and maybe even into next week, is just kind of walking through each of the steps of this, what we're doing, what those functions are trying to do, how they're working. And then your goal is essentially to take that code, you maybe have to tweak it a little bit, but essentially just replicate it on a parallel data set. So hopefully it really should not be that hard. You should have pretty much 90% of what you would need to do is already provided to you in that notebook. There may be like a couple things that you may need to tweak out. There may be some things you'll have to kind of tweak a little bit, but basically everything that you'll need to succeed is right there. As I mentioned, there's no one right way to implement this. The code that we provide is there as a resource for you to use, but if you've done data science previously and you have some great code blocks that you just kind of like using for your graphics, like feel free to use those. If you find some stuff on, online, like feel free to use those. We want you to see you go through the steps, but we are completely agnostic to the methodology. Also important to note, you will not be graded on model performance. For the only thing in which the only project for which your actual model performance is probably going to matter is going to be project 3. And even then it'll likely be for like extra credit. And actually we can talk a little bit about project 3 at another point, because I think that's actually going to be kind of exciting. But we just want to kind of see you go through. We want to see that you make the code work, that you get the outputs, that you sort of do the analysis. We're not looking to say, oh, well, you need to achieve a classification accuracy of at least 80%, otherwise you fail. Nothing like that. So, as I mentioned, essentially what we're going to be looking for you to do is as a first step, and this is when you're working with data, as a first step, you will always kind of want to get acquainted with the data that you have. So, there's going to be you're going to have to do the work around loading the data into your thing, and then kind of playing around with it. So displaying the first few rows so you can kind of look at what the sample inputs and outputs are, look at the type of data fields that you're dealing with, again, to kind of understand, what opportunities you have, what you need to work with, what kind of limitations you have in terms of your data, generalizing some statistics for your data, and just helping to kind of visualize it. And again, all of that is kind of just designed to inform you of what it is that you're working with. So, what's the game field? What are the goalposts? What are the opportunities and the restrictions that you have? And so that's kind of that first step. So it seems a little bit like tedious, and it's like generate histogram, generate box plot, generate these things. And it's just like, okay, blah, 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 blah. But the reason you're doing that is ultimately, and this is kind of a theme that we're going to come back to, I think, multiple times in the course. There isn't always a right answer for how to approach this. And like, there's a reason. Are you guys familiar with like the website Kaggle? Have you heard about that? Okay, it's this big data science competitive website, and it's really, really cool. Companies, foundations, governments even will put up data sets, and they'll put up a prompt, and they'll say like, hey, help us help us like improve our model, help us prove the thing. Like I remember, and some of these are really big too. Like I remember, I think a couple of years ago, Zillow posted they wanted to improve their predictive algorithms for it. Cause if you ever been on Zillow, that's a real estate site. They have the Zestimate, which is like their estimated retail, like how much a property is worth, how much a property will sell for. And so they wanted to improve their Zestimate. And so they threw a bunch of data on there, and they hosted a contest, and they're typically cash prizes. These are typically like the Zillow one was $1 million cash prize. And part of what I kind of want to emphasize here is that there's a reason you see that sort of competitive environment when it comes to data science that you don't necessarily see in software development. And that's because with data science, there's a little bit of like an X factor. It's almost more of an art than a quote unquote science. You don't necessarily know what approaches will work. You don't know which learning model, which tweaks, which things will work. And part of what we're going to kind of teach you to do in this course is to understand enough of the domain to kind of play around with things. But a big part of like when you do data science is kind of coming up with your own recipe for that. And part of that recipe, for instance, is going to be to figure out which, you're given this massive data, what data fields are important, what transformations you do to your data, how do you change your data, how do you, fix your data, prepare your data to include and to feed into your model, because that's a huge part of ultimately what's going to make your model work or not. And different people will take different approaches, and they get very different outcomes based on the choices that they make. So that's why like this part up front about doing that visualization, doing that familiarization is so important, because two people will look at the same data set and will draw very, very different conclusions about what to include, what not to include, and what changes to make. And that's, and we're not even getting into the model itself. We're not getting into like what learning algorithm you use, what permutations of that you use, all those things. That's just in terms of prepping your data. So then talking about the data prep, again, you're going to spend a lot of time doing that. There's going to be, you're going to have reasons to drop certain data elements. You're going to have reasons to keep in certain data elements. You may, we're going to spend some time talking about data augmentation. So trying to sort of infer new insights or sort of analytics that you can kind of feed into your data that isn't necessarily immediately apparent to a learning model. And then as we had sort of mentioned in lecture, ultimately then you're going to divide your data set into your training and your testing cohorts. And let me pause there and actually kind of just do a quick refresher. Do you guys remember the whole train test and like what that is and why that's important? Okay. I think Professor covered that in lecture, didn't she? Did she not?
Yeah, so like basically once you collect all of your data, like you need to reserve some of it for testing. Otherwise, if you use all your data to train, then you don't have any more data to test on. So you just have to reserve part of it. She said usually an 80-20 split is done where 20% is test data, 80% is trained.
Perfect. Okay, yeah. So that's exactly right, right? So in statistics, like in machine learning, you're using sort of a set, you've collected a set of data. Hopefully it's quality data, and you want to use that to build a model of the universe. And then there's always the question, this is something we're going to this is sort of, there's a delicate balancing game here. We're going to go into the weeds on this really, really closely here, but you want to try and make a model that generalizes as well as possible. You want a model that is as universally applicable as it can be. And one of the biggest challenges oftentimes you run into with machine learning is the notion of overfitting. And have you guys heard of overfitting? Is that a concept that you guys have run into? Okay, yeah. Ah, heck, why am I even teaching this? You guys all got this. Okay, class dismissed. We're done for the day. Okay, but overfitting is essentially, yeah, you all are too agreeable. So the idea is that, right, all in an ideal world, the data that you collect sort of maps perfectly to the universe of data out there. Realistically, of course, that's never the case. And part of the challenge with statistics is always like trying to figure out and trying to hypothesize test and how to sort of generalize your findings from that pool of data that may or may not be representative of the broader universe. And the problem with machine learning is this idea that you can fit a model so perfectly to that particular set of data that you have that it'll work perfectly for that data. But the moment you introduce anything that's not part of that, it just completely kind of falls apart. And so, the training and the testing cohorts, and there's a lot of really cool things that we can do in terms of train test. For project one, we're going to just do the easiest way of doing that, but there's a lot of really cool ways in which we can kind of split our data, certainly. But that's precisely the idea. For your training thing, that's what you use to build your model. And then your testing is that the data that you're setting aside to then look at and say, okay, well, how well does this model that I have built, how likely is it that it's going to reflect in the universe of data? And then the last thing that you're going to kind of do in terms of your data preparation is a data pipeline. And again, this is a very high level. We're going to go into more details about this. But the idea there is, if you think about moving your code from like experimentation to production, if up until this point, you've just been poking around, trying different permutations, trying different things, which you will do. When you're doing a data science project, you try removing different columns, doing different things, seeing if you can improve your outputs. Once you've settled on the recipe, you want to standardize that, right? Like if you get hired, for instance, like if you're doing, okay, good example, like project one, you're using an Airbnb data set. Let's say Airbnb hires you to do predictive modeling. And let's say, they want you to predict, they want to build I think this is actually what we're asking you sort of to do. They want you to build a recommender engine for pricing. So let's say there's a new host who gets on the platform, they're listing an apartment. You want to be able to give them a suggested price. And you want that sweet spot where it's not, they haven't priced themselves out of competition, but at the same time, they haven't priced so low that they're effectively kind of leaving money on the table. So ideally, you're going to train on the model you have. You're going to settle on a model that seems to work. Then you want to have your process moved into production. What that means is every time a new user comes in, they input the information. you make whatever data prep you need to do, you plug it into your model, and then you return an output. And that's all kind of standardized. It's all sort of a single function call. It's all scripted and automated. And that's essentially the whole pipelining step. And then finally, once you have prepped your model, you are going to actually sort of begin to play around with different models. And the professor spent, I think, a while talking about this in lecture the other day about, the different kind of predictive models that you can do. And particularly in this case, where we're doing a predictive thing, oftentimes you'll use some kind of regressionary model. You're going to train it, you're going to test it, and then you want to report out the results. And then we talked about that in lecture, like how do you measure success? And that's really, really important. And like, do you guys remember? So professor had sort of asked this, what is the advantage of squaring doing the mean square? Like, why are we squaring that function? What does the squaring do in that? Does anyone remember that?
It basically, like, the negative values or any negative values wouldn't have an effect on the overall error. Good.
So that's one really practical function of that, which is that because, just looking at this visual, you have if the blue line is your predicted value and your purple points are going to be your actual values, there's going to be that error, and the error terms are going to be this red thing, which is just your y minus y hat. Now, so the first thing we kind of need to note is that, yes, if you do not sort of correct for the absolute value of your error, you could, in this case, get something where your error approaches 0 just because your positive error and your negative error are effectively canceling each other out. So yeah, so squaring it is a really, really easy, quick and cheap and dirty way of doing that. Do you guys remember another? Okay, let me see here. I think somebody in the chat kind of got punishes large errors. Yes. So that's another approach of like why you might want to do a square versus just taking, for instance, the absolute value of the error, which you could totally do. And that's another kind of error term that we mentioned in lecture. So the idea of squaring your error is precisely the idea that it disproportionately punishes larger errors. And this is something that we're going to spend a good deal of time talking about in lecture, particularly when we get to classification exercises, is that depending on what your goals are, it will depend very heavily on what metric you use for it. So, if you just take, for instance, the absolute value and take the average absolute value error versus a squared error, let's talk about a use case. When do you think it may make more sense to take MSE versus, I forget what the acronym is for the other one, but mean, whatever the absolute value error is. Oh, MAE, yeah, thank you. Yeah, pop quiz, I was just testing you guys, haha. Okay, well, let me give you an example that might, an obvious example of this. So let's use our Airbnb thing, right? We want to create a predictive model. Okay, good. So people are talking about data has a lot of outliers, and that was something we talked about in the lecture, right? And that's where your data visualization step is going to be really important. Where your data has a lot of outliers, you may think about how that's going to impact that. And actually, outliers are probably a good example of where you may actually want to go the MAE route, because if you don't care so much about the outliers, those outliers may kind of force you to take approaches that you wouldn't otherwise want to go down. You may just want to discount or discard those outliers. But talking from like a business case perspective. So again, going back to Airbnb, their goal is this, going to say, look, we want our new hosts to have like a ballpark price. It's okay if it's a little bit off. It's okay if, starting out, it's not perfect, but we definitely don't want this to be excessively bad. We want to give them something that's in the range. So So it's okay if there's like a small degree of error. These type of errors are okay. We just really want to avoid these type of errors. We want to avoid being far off the map. So that's an example of where you'd probably use MSE. And talking through like your business case. So there's a data side of it, understanding like the parameters of your data and the limitations you have. And then there's also your use case, your business case for this. So, okay. And then just like really quickly, again, for your final submission, you are just going to export your Jupyter Notebook to be a PDF, and you will then upload it to Gradescope. And again, we're just kind of looking to see that you've scripted it properly, that you're getting the outputs that you want, that those are being generated correctly. We're not going to be running your code. We're not going to be doing anything like that. We just kind of want to see that everything is working the way it should. And your due date will be 2 weeks from this past Thursday, right before class. We debated that, and actually, if you have feedback on that, let us know. But we kind of felt like y'all have enough dates and times to kind of remember that just tethering due dates to actual lectures is maybe just the easiest way to do this. Because that way, you already know 10 a.m. Tuesdays, Thursdays, I have course. So just remember, oh, whatever assignment is just going to be due immediately beforehand. I don't know if that is helpful or not, but we just kind of figured less chance of people kind of forgetting submission deadlines or thinking, oh, I thought I had extra days, whatever, and so on and so forth. But y'all let me know if that's the case or not. Okay, so let me pause there at a high level. Does that, where's my thing? Does that make sense in terms of what we're trying to do, what your project is going to be doing?
Yeah, sounds reasonable. I've been following along.
Okay, awesome. Well, if that is the case, so then I think for the rest of the time here, and again, if anybody has any questions, please interject, please let me know. But I think the best thing that we can kind of start doing is just walking through these and understanding kind of what you're doing. So just so you're sort of aware of how this notebook is structured, we give you 2 data sets. The first is looking at California housing. And so we're going to, do an end-to-end run on sort of data exploration for California housing. I'm going to talk you through some of the visualizations for it, some of the kind of analytics that you can do. Then we get into the data preparation space where I'm going to look into like augmenting your features. We're going to talk about how to deal with your incomplete data, imputing those features, then ultimately sort of preparing and pipelining it, then selecting your model, training your model, and so on and so forth. Oh, did I? Shoot, is this out of order? Oh, no, why do I have this splitting the data set there? Did I do that right? Oh, not a huge deal. Okay, these boxes are supposed to be reversed, but not the end of the world. And then the part that you're going to actually fill out is right here at the end. You're essentially going to be asked to pretty much recreate that entire step-by-step thing, but you're going to be asked to do it with a separate data set of Airbnb rentals in New York City. So that's sort of effectively what you're going to be asked to do for this assignment. Okay, so going from the top, just all of this is just kind of importing a lot of the libraries that you're going to be using. You'll probably just be able to reuse all these, even your inputs, for your data set, the paths, the relative paths are the same. They're in the same directory. So I don't think you need to you can pretty much just reuse all these. I don't know why we have NumPy imported here, but we don't have pandas up here, but whatever. So then the first thing that you're going to be asked to do is to load your data. And here we previously have sort of defined a path for you to import your data set. You don't really, so you can just kind of reuse that thing, just replace housing CSV with, I think it's Airbnb.csv, and then that'll kind of load it into your thing. And then, the first thing I mentioned is this head function right here, which again is just kind of a really nice, easy way of visualizing the cells that are in your data set. And I think you can modify your, yeah. So if you want to, you can also modify the amount. I think it defaults to 5, but you can change your outputs here as well. And so as kind of a first step, you can kind of begin to look, okay, so the data sets that we have for housing, we have a latitude and longitude, we have a housing medium age, so the age of the housing, total rooms, total bedrooms, population. I'm not entirely sure what all of these. Oh, I think these are by, I think these are, I think this is like within each sort of discrete data points. What's the housing medium age? What are the rooms that are available within that? The total amount of bedrooms, the population in that cell, the number of households, the medium income, medium housing value, and then there's an ocean proximity thing. And the first thing that you're going to note is that your data is going to have different, yeah, so I think it's like, I don't exactly know like whatever the geographic parcels are. So here, if we jump down to the data visualization, so you can see here we have like a lot of different points. And so I think for each point, there's sort of an associated number of available rooms, number of available bedrooms, population associated with that, and so on and so forth. So, but again, that's precisely why it's so important to kind of visualize this data and output this, because total rooms, if I was just, noticing, I might say, oh, that's total rooms per house. Well, obviously it's not total rooms per house. That's why it's so important to just kind of just do this head thing, just call it and look at it. So the first thing that you may notice here is that your data set is going to have different types of features. And the things that you'll note here is that, you'll generally have floats, you will have integers, and then you have objects, strings, things like that. So near bay, this ocean proximity thing here is going to be a categorical. Well, let me get to that in a little bit. And another kind of useful function that you can do this is your info thing. And this is going to be really, really helpful for you for multiple reasons. The first thing is that you're going to see sort of what the column is, the column name. You're going to see the data type, and then you're going to see a non-null count, which is super, super helpful. The first thing is your data type. So one thing to note with your models is most of these machine learning algorithms, virtually all of them, are quantitative based. I can't pass ocean proximity as it stands into a regression model. That's, right now that's gibberish. A regression analysis has no idea how to handle near bay in a thing. So the first thing when you're doing this, when you look at, whenever you see an object, you're going to know that you're going to have to do something with that. You'll have options. Well, let me actually turn and ask you, what do you think we could do ocean proximity? What do you think we could do to that?
So I don't think it'd be right to just quite enumerate it, because there is some reasonable ordering, like you can be near bay, and then reasonably near bay, and then maybe in the middle, and then one might be extremely far away. So it's probably in our best interest to look through all of them and then enumerate them with some ordering.
Perfect. Okay, so I think and great. I don't know who said that, but great thought, right? So the first thing you're going to look at is you're going to say, well, I need a little bit more information on what this data field actually looks like. And so if you look down here, so we do have some specific things. I'll kind of just run through this really quickly. You can also, so you notice how we were able to call housing.info. So that's where I'm referencing the entire data set. I have the ability to call specific columns within specific features within my housing thing as well. So if I want to just look at ocean proximity, I can do that as well. And then I can also, so not only can I call a particular column, I can also use this function, iloc, to call a specific row. So a specific sort of instance of your data, right? So if you're looking at, this being the columns being your set of features, rows being your individual data points. So you can use that to kind of navigate and reference specific either features or specific elements. So, but to your point, so before we decide what we want to actually do with this, we kind of need to understand with what we're dealing with. And so there's a really, really nice thing here, a really nice function called value counts, which will then give you a nice breakdown of all of the discrete values found in that column and their associated counts. So in here, what we see is, okay, well, actually, there's a sort of a limited number of outputs here. We can have island, near bay, near ocean, inland, or less than 1 hour from the ocean. And we can see sort of counts associated with that. So then, and this is kind of important because it is also quite possible that this could be just a plain text field, right? You could imagine a scenario in which somebody's just randomly inputting things. So they could say, one computer can say near bay or near the bay or just around the corner from the bay, right? Which is really not useful to work with. This tells us that there are a finite and discrete set of values for that. And that's a specific type of data that we call a categorical, which means that there are sort of a predefined finite set of values associated with it. So we know that we are going to, so assuming we want to keep this data, we're going to have to do something with it. And we're going to get into exactly the types of things that you can do with it. But just to kind of be aware, that's sort of the first thing you're going to look at. So you may, so looking at this, you're going to say, okay, well, I either want to keep it or I don't want to keep it. And here's what I want to do with it. The next thing that's really, really useful is this none-null count. So again, another thing that we're going to get into, your data, generally speaking, you need to be able to figure out how to handle null values in your data set, because null just means there is an absence of a value there. It doesn't mean that you default to 0, although maybe that's the choice you choose for it. It just means that for that particular row, there is not a value there. And generally speaking, your model does not handle that well if there are instances where it doesn't have a value. So generally speaking, you need to figure out what you want to do with that for those things. And this just kind of gives you a count to say how many none-null things we have. Well, we can see, for instance, here, lat, longitude, all of these we have 20,640. So chances are these all don't have any null values. Total bedrooms, however, is only 20,433. So it looks like that one actually, we have a problem. We have a lot of null values in that particular feature. And again, we'll get to that in a little bit, but we're going to have to come up with an approach for a strategy to deal with that. Any questions on kind of some of these some nice sort of info that you can kind of pull up on your data? Okay, the last thing that I'm going to do specifically on just sort of nice like text-based information that you can kind of pull up is the describe function that you can call in your data set. And here, as you can see, it returns a really nice set of sort of summary statistics on each feature. So it'll give you like the total raw count. It'll give you the mean value, standard deviation, min value, your 25th, 50th, 70%, and max value for all of these. Now, you will note that you do not see our ocean proximity thing show up here. And there's an obvious reason for that, because it's an object. It's not, it's not a float or an integer. There are no summary statistics that are going to be returned for that. But again, hopefully kind of you're beginning to kind of see when we talk about like playing around with your data, exploring your data, sort of understanding, getting to understand the data set that you're working with, how helpful these these functions can be. Any questions on what we've covered so far? Okay, so then as a next step, we're going to get into visualizing your data. And there's a lot, as you can see, that you can do here. And we're going to kind of ask you to do that as well. But just kind of, the first thing to note with sort of Python, and that you'll sort of be using a lot, is that in terms of how you feed in, so the way sort of Python takes inputs to its functions is, generally speaking, right, your function will always be in that sort of closed parentheses. And then if there are specific input variables, you can input those variable options within those parentheses. And if you just do the closed parentheses, it means it'll just default to whatever the default settings are for that particular thing. And if at any point you want to kind of play around with the size, if you want to, like, the amount of, in this case, it's the amount of bins that you have for this, you can always kind of just look at the documentation, and it'll oftentimes sort of walk you through all of the various things that you could do with this. So the first thing we kind of show you here is histogram. And again, histogram is kind of just a nice visualization of your data, and sort of gives you a nice kind of breakdown of your sort of the how your data is distributed. And in a way, I think it can be a little bit more intuitive than just kind of looking at this, because, okay, this will give you obviously information, but this can give you some really kind of nice sort of information about this. So like, so I believe longitude is horizontal, correct? Is that generally the case? And then latitude is vertical. Yeah, okay, cool. All right, awesome. High school geography coming through for me. So unsurprisingly, if we're looking at a map of California, it's not really surprising that latitude-wise, our housing is going to cluster in certain areas, right? So, this area here, I'm not sure if it's reading north to south or south to north, but generally speaking, right, let's assume it's going north to south. Actually, let's assume south to north, right? We can assume maybe down here, this is like the San Diego area. This area here is OC, LA County, Southern California. When you get up to like the sort of the mid-state coastal area, you're not really getting into much. Then you hit this pocket of density here with the Bay Area, and then you kind of get into NoCal, and you're not really seeing much there, right? Kind of makes sense. Again, longitudinal, we could sort of expect that too. You're going to see as the thing curves, maybe this area sort of corresponds with the heaviest density in terms of coasts. And then maybe like when you're looking at like Bakersfield, Fresno, certain other areas, and even actually Southern California, because the state kind of loops down. So like, right. So probably around this longitude, you see a lot there. Unsurprisingly, things like total rooms, total bedrooms, population, those are going to be more normally distributed. That's not so surprising, I think. Same thing with income. We kind of have this funky thing here going on with medium housing value, where we do kind of see long tail, but then maybe all this is like coastal stuff. You do have like a crazy amount of very high income housing as well. But again, really like, and we talk about like all these different things like box plots, histograms, things like that. These are all like really, really useful and intuitive ways of like looking at your data and kind of understanding the type of features you have. And then we walk in just like before, how we were able to sort of call out a particular column or just do the entire data set. So again, you can just call the whole data set and it'll generate histograms for the entire thing, but you can also just call a particular column within it and then do it. And by the way, this PLT is the matplot library. I think it's a really, really useful set of libraries for visualizing your data. So we're not really doing much here, but I actually sort of cut this because we originally the sample code was a bit more complicated than I ultimately wanted to give you. So I actually cut part of it, but this is still a really, really useful thing as well. And when we get into sort of data augmentation, this can be a really, really useful step for you all to do, which is, so you can see here, right? So right now, for instance, we have like income category. Right now, that's a floating variable. Well, we may want to sort of do buckets, right? Because when you talk about housing, oftentimes we're going to talk about like high income neighborhoods, middle class, low income neighborhoods, right? We may kind of talk about it in terms of those categorical values. So it may be useful for us to kind of break down what has been what has been sort of a discrete set of sort of almost like a continuous data stream into a sort of a set of discrete values. And so that's essentially what we're doing here. So I don't think for the actual exercise you're going to be asked to do that. In fact, I'm almost positive you're not going to be asked to do that. But this is kind of a cool example of how you can take your data and essentially cut it. You can define, again, you're sort of the number of sort of areas that you want. You can associate values with it, and then we can kind of see, okay, breaking it down. So here we're doing it into quintiles. We're looking at like 20%, 40%, 60, 80, 100%, whatever, and just looking at sort of how your data breaks down accordingly. Again, really useful feature. You're not going to be asked to do that for the project itself, but it's kind of a cool thing to know. You can also actually like visualize. You can actually do a scatter plot here. And so we kind of show you, I'm not going to go into too much detail with this, but you will be asked to do something equivalent for Airbnb rentals. And it kind of just shows you sort of some cool things you could do. So this is just your basic brute force plot. Here we do kind of a really cool thing where like we show the plot by density. And so you can see here that it kind of color codes the dots based on the density. And then this is kind of a, I wouldn't necessarily spend too much time dwelling on this unless you're really interested in doing this, but this is kind of like a really nice way of like taking this kind of default map, which sort of looks like California, but like correcting for longitude and latitude. There is a blank map of California that we sort of reverse impose in the background, and then just color coding the density and adding a value table. So you're not going to be, you're basically asked to do something like this for the homework, for the project. You're not asked to really go beyond this. If you want to play around with it, if you want to kind of try to hit something like this, you can play around with this code and try to kind of replicate that. We did include a map of New York that you can use to do that. But again, that's if that's how you get down on a Saturday night, then go crazy. But that's sort of out of scope for what you're expected to do for project one. Okay, and then sort of the final part of here is just looking at your correlation matrices. So if what we're trying to build a predictive model for is your medium house value, you kind of want to look at how nicely sort of these things correlate to that. And if you've taken sort of some statistical courses, like you'll know that like a 100% full correlation is like a 1, and if it's sort of completely inversely related, it's a -1. So unsurprisingly, medium house value perfectly correlates to medium house value. There's a shock, but everything else sort of we have sort of descending things. So unsurprisingly, medium income is almost a 0.7. So there's almost a 70% correlation there. Again, very intuitive, right? People who earn high incomes will likely live in expensive houses. That makes sense. Some of the other things we're obviously seeing less correlation, but still some correlation there. And then, unsurprisingly, maybe like population is negatively associated with that, right? Wealthier areas will probably be less dense. That makes sense. But then again, cities may also be very high income. And so in that instance, so that's why you're seeing a very weak correlation there. Latitude and longitude, again, very weak correlation there. Not really surprising because you're going to have high income and low income areas across the state. But, and again, you can kind of just visualize those relationships as well. So you can kind of sort of see where your data, if you plot one against the other, kind of, does it sort of come up with a really, really nice thing, or does it come up with is it kind of a little bit sort of randomly distributed? So in terms of like understanding the relationships between your features, again, those are things you're going to be asked to do for this project too. Simply, again, recreate it. It's a very sort of easy thing to I think generate. You can pretty much just copy and paste this code and just change your input variables, and you should be good to go for that. Okay, now we get into augmenting features, and there's a lot to say about data augmentation. That, by the way, is the cry of my soul, despairing from existential dread that is 2020 or 2021 now, which we all thought was going to get better, but somehow is even worse. Let's see. So there's a lot to be said about data augmentation, and I'm not. And for this, we're kind of doing like the easy. For this first project, she's crying. Exactly. She's our little mascot. So this is kind of very basic augmentation. And you can see here, what you're literally doing is you're creating a new column. You're doing rooms per household. And that's just obviously simply a relationship where you take the total rooms, divide by the total number of households. And that's, on some level, that's sort of like an easy thing to say, right? Because we were looking at this and saying, well, we have a lot of rooms, but that doesn't really tell me how big the average house is. But if I divide total number of rooms by total number of households, that will give me kind of a sense of how big the house is. Same deal with bedrooms per room. Like, what is the ratio of bedrooms to total rooms in my house, and population per household? Again, that was another thing we wanted to get. Like, what is the population density? Because something like LA County or Orange County may have a very, very high density, but something like Orange County may have a very high population, but also maybe their population density isn't that high because they're doing a lot of density things. So these are like features that you can augment. And this is essentially how you would do it. It's this basic calculation. You create a new column here that will actually be put into your data frame. And it's just kind of referencing the relationship between those. And then you can, again, look at the relationship between that. And, look at here. Okay, so unsurprisingly, right now, so these are our new features. We have rooms per household. We have, what was the other thing we did? Bedrooms per room, and then population per household. And we can kind of look at how these new features correlate between them and plot those. Now, I'm going to pause with this. I'm going to put a bookmark in the data augmentation discussion, because there's a lot to be said about what features are useful or not useful to augment. And what I will note here is that these features are actually not particularly useful to augment. And does anyone know why that's the case? Okay, I will tell you. And the reason that these aren't particularly useful features is because these are directly sort of direct mathematical correlations, right? So these relationships are sort of directly capturable in their individual, in the individual fields they are, because they're a direct algorithm, arithmetic relationship. When you plug the previous models in there, that relationship should already be captured, and the coefficients associated with them should largely already be captured. So doing this doesn't necessarily, from a learning model perspective, help you. It maybe helps you in terms of understanding your data a bit more, but it doesn't actually kind of help the learning model, because that information is kind of already there. When we talk about augmenting features, usually what we're talking about is doing things that aren't necessarily sort of directly discrete. And a good example of like an augmented feature I think is actually pretty good is this income category thing, where you're doing essentially a non-linear conversion to that, where you're taking what had been a discrete linear sort of set of thing and turned it into a categorical variable based on middle income, upper income, lower income, things like that. So non-linear transformations like that create new data, those are oftentimes much more useful features to augment and can actually generate real value add to your data sets. But again, just something to be aware of, not something you're going to be asked to do. You will be asked for the project to essentially do this exact thing. But again, very, very easy, very sort of intuitive to run. Okay, let me pause there. How's everyone doing? Y'all hanging out? Y'all doing well? Okay, well, let me actually ask you this, because we've already gotten sort of through the first 2 steps in our data, sort of running through our data. And I've been talking at you for a solid 90 minutes now, and that's kind of brutal. So I didn't prepare an official breakout session, although I can obviously give you some topics. Would you guys like to press on? Would you guys like to kind of have a chance to do sort of like a breakout session and maybe go through some of the data science topics that we've sort of talked through today? What are you guys feeling like? I'm hearing 1 vote for pressing on. You're fine with continuing. Okay. All right. So far, I'm hearing no. Well, I guess anybody who isn't cool with pressing on probably just ghosted already. So maybe that's not entirely surprising. Okay. Man, I goofed not having lunch before this. Okay. I know you're all eagerly awaiting incompleted data set, aren't we? That's what we're really looking at. So remember, like way back up here, I was talking about your null things. Oh, hi. You want her to come in? Okay. Hey guys, who wants to meet Savannah? She's awake. Hello, sweetie. Hello. Yep. Let's make sure her pants don't fall off. Hello, everybody. Okay, Savannah, do you want to tell the class how to deal with how to impute data? I know it's exciting. Hello, everybody. Hello. Hello. Okay, we get a 2-minute baby break. How's that sound? You little Boba, you smell bad. Okay. Hello. All right, that's Savannah. Let me give her to her mommy. Okay. So, and then let's see here. So let's say you are dealing with data. Back to data set. Supposedly I actually have to do meaningful work with you all. That sucks. Okay. Processing our data. So first thing we need to do is dealing with our incomplete data. So remember, we already did our info. We already able to pull that, but let's kind of look. So there's this nice little thing is null function. So we can return some right. So here, this is a nice little function I put together. Variable sample incomplete rows. I pull from my housing is null any, which says like any. So it's not limited to any particular column, anything that has a null value. And then remember, head just returns top 5. And then I just print out that thing here. Now remember, this kind of makes sense because when we were looking at before, when we were doing our count, the only one that kind of had that discrepancy was total bedrooms, right? If you scroll back up to here, where was it? Our non-null, everything else was 20,640. The only one that had a discrepancy was total bedrooms, 20,433. So unsurprisingly, when we're sampling our data, we have these NANs. And remember, and we'll kind of, again, spend, I guess, a little more time talking about that a little bit, but I just kind of want to tease that up. Null values are different than 0 values. because a 0 value means something, right? Total number of bedrooms. In this case, I can't just treat that as a 0 because typically that's not going to be 0, right? If this medium housing value is 161,000, chances are there are not 0 bedrooms for that space. And typically speaking, putting a 0 value in there is not going to be good. In fact, doing that will probably completely mess up your model. So what do you guys think? What are some options that we could do for this? What are some strategies that we could take for handling that? Okay, good. Remove those data points. So the first thing it says, and that's our first option here, simply drop the rows that have that null value. And you have a nice little, drop NA thing that, so because you already have your sample complete rows, you can just kind of drop the ones that are null values. Okay, so that's one thing that we can definitely do. So the specific data points that give us those null values, they're gone. Goodbye. Ain't got time for that kind of drama. Okay, what else could we do? Make it equal to -1. Okay, so let's talk about that specific thing. So the other thing that you could do, and I assume that's like a nonsensical value. Okay, so you want to have something that can kind of feed into your model, but so it's quantitative, but it's nonsensical. That's interesting. In this case, I'm not necessarily certain that that's going to be a good approach because, again, you are feeding in information because this is a numeric value. Total bedrooms it's not categorical. It is numeric. There's something there. By saying -1, you are sort of stating it in relation to ones that have positive values. So that's obviously, so in that case, I'd probably advise against doing that approach. But it's not always a bad idea to say, let's assign an arbitrary value. Whenever there's a null thing, assign an arbitrary value. So that's obviously something that we could do as well. Okay, what else? What are some other approaches you think we might take to dealing with these null values? While I try to stealthily eat. You think class participation is for you all? It's just for me to eat my food. Okay, try to estimate based on households or population. So that's an interesting thing, right? So maybe you could kind of look at, going back up here, you could try and like correlate. So up here, we did correlations against median housing value. So maybe you try to correlate for the imputed things and you try to say, okay, well, is there, does that feature, does it correlate pretty strongly to some of the other features such that we could maybe create sort of an inferential model? So yeah, so that's actually so Jacqueline, that's like a really cool kind of approach to that. Maybe there's nice correlations that you can leverage to kind of, again, create a predictive estimator that will likely get you close to the truth. So there's another very simple option here, and this is the thing that we do here. We mentioned that you could drop the rows, but you can also just decide to drop the column itself. You may just decide that the feature is just simply not worth preserving. And generally speaking, when would be sort of a good, when might you want to take that approach?
I think if it correlates strongly with some other feature or it has zero correlation with the actual output, then you should just drop it, right?
Good. So that's one really good way of thinking about it. Going back to your correlations, right? If there's almost no correlation with your desired feature, you could say chances are this is not going to be the thing upon which your model turns. And in fact, you doing an imputation strategy may very well introduce errors and may make your model less accurate by doing it, because you're essentially manufacturing data that may or may not reflect the real world. So that's a really good example. Another thing to consider about is the volume of null things within that. If you have so many null values within that feature that the likelihood of the remaining values being statistically representative, that you can kind of build a model, maybe, low enough, you may say it's just simply not worth, I just don't have enough good data in that feature for me to want to include in the model. So that's kind of another thing. And like in this case, and if we look at that, it's not terrible. I mean, we're essentially looking at like out of a 20,000 data set, we're essentially looking at about 200 null values. So that's really not terrible, but you could kind of see something where like if it was 10,000 as opposed to 20,000, then you might say, you know what, there were so many null values there that it's probably not worth keeping there. So again, something to think about when you're kind of making that decision. Another strategy that you may want to do for where am I here for this? Okay, another strategy that we talk about here is just sort of replacing. So we talked about doing an arbitrary value. You can also just replace it with the mean or median value as well. You might essentially say, well, particularly if you're looking at your distribution, and particularly if it's sort of a nice normally distributed thing, you might say, well, you know what, let me just input the median value for it, because chances are, I think, so total bedrooms, let's look at that, right? So that's a nice, fairly normally distributed thing. If I just impute my median value, chances are it'll be fairly reflective of the reality. So again, another approach that we could potentially take. So this just kind of talks through that. And, that strategy, just sort of when you're thinking about it, that's the kind of thing that you may get asked, just sort of for your awareness, that's the kind of thing that you may get asked on the homeworks. Like that's a reasonable question that we may ask you. Like, talk through a couple strategies that you would take for dealing with incomplete data and talk about some of the advantages or disadvantages for them. Like, when would you leverage one of these strategies or not? I think that's a very reasonable question that we might ask on a homework. Okay, then we're going to get into actually preparing your data. So the first thing that we're doing here, and because we're pipelining, it works a little bit differently, but so the first thing that, and this is like mistake 101 that people make with this is, so when we talk about just, again, data 101, when we talk about labels versus features, what's the distinction? What are we, what do we mean by that? Anybody? Bueller? Yeah. So right here, there's this step here where we are essentially taking our labels, dropping them and copying them. So my question was, what are labels in the data set? What is this? And what are labels versus features? What the heck is that?
Aren't labels just the names of each column?
Okay, good. Usually, yes. So usually when you think about labels, you're thinking about these up here: longitude, latitude, housing, total rooms, things like that. So there is a reason why I kind of wanted to pause here and talk through this. Here, labels mean something slightly different. Labels in your data set is essentially what you want ultimately your machine learning algorithm to learn. And so generally speaking, taking a step back, machine learning algorithms will typically do one of two things, or classify. So it'll either predict or it'll classify. If it is predicting, and so firstly, for this project, are we doing a predictive? Are we developing a predictive machine learning algorithm, or are we doing a classification algorithm? And what is the difference? So let me, let's go back to basics here. Okay, so what is, I guess, so again, really, really back to basics, what would a predictive model look to do? Okay. So a predictive model, you're essentially trying to predict a value of something. So for instance, where is my lecture notes here? A predictive model says we have a data set here. If I'm given a new set of X, a new data point that has certain X values, can I predict where it'll fall? In this case, in the Y axis. So essentially a predictive model, I want to return a discrete value and that will be a prediction of its real Y value. So in this case, the label for a predictive regression is your Y value. Let me put that into plain language. The sample project that we're doing, where is it? This is looking at your the median household value. So what we're trying to do is to predict a model to say that if I give you a bunch of data on where in the state it's located, what the house sizes are, what the amount of people, population is, things like that. Can I predict how expensive the house is? If I give you all that data, can I develop a predictive model that will predict the associated median housing value? So that's an example of a predictive regression. What is a classification model? Okay, divides, inputs, indicate. Good. Good. So the classic example of this is a classification thing, right? If you're doing like an image classification thing, I have a data set full of images and cats and dogs, and I want to train a model to predict if I hold up an image, is it a cat or is it a dog? Right? Hot dog, no hot dog. Exactly. That's an example of a binary classifier. You want to sort of associate a particular thing with it. Yeah, exactly. It predicts labels. Right. So like in this case, we're not exactly doing that. But for instance, you could totally do a classification exercise around ocean proximity. So, in this case, I would feed in all the other data and I would say, okay, I want to try and predict whether or not, the associated property information I'm giving you is an island, is near the bay, near the ocean, inland, or less than an hour from the ocean. So you're predicting the labels, essentially. So back to this whole thing here. So for preparing your data. So the first thing we always want to do is make sure that we're treating our, removing our labels from our data. Now, okay, so again, the labels is just the feature that we're trying to train our model on. So in this case, for our predictive regression, we're doing median house value. We're trying to build a predictive model for what this is. And then if it's a classification exercise, we would remove the categorical variable that we were trying to classify around. So those are our labels. So, okay, so why as a first step do we remove them from our data?
If they had the answers, then the best model that you could come up with is guess the answer with the answer.
Yeah, perfect, right? Exactly right. If I feed my label into my training data, then assuming your learning algorithm is mildly competent, it would look at the correlation. Where's our little correlation? And it would say, oh my God, I have this one parameter here that perfectly correlates with what I'm supposed to predict. Hallelujah, my work is done. Just find this and return it. Great, right? So you will get, if you pass in your labels into your training data, you will get fantastic results. You will get accuracies of, you should get 100. If you're not getting 100, that's almost interesting in its own right. But yeah, so exactly right. If you're giving them the answers to the test, don't be surprised when, they're returning 100. So, right. So exactly right. If this is what we're trying to predict, let's remove it from our data set. Okay. So then there's this whole pipeline, and oh boy, isn't this fun. I think because it's already like 150, I feel like this is kind of a good space for us maybe to stop, because this is a huge wall of code and I don't want to deal with it right now. And there's a lot for us to talk about with this. And next week, we're going to spend some time talking about this. We're going to talk about how, like, things like scaling your data. We're going to talk about one-hot encoding your data and label encoding your data. We're going to just talk about how that constructs. And then we're going to talk about the actual implementation of splitting your model and training it and returning your actual outputs. So I think that's kind of like a good space to stop. So let me pause there. Any questions? So let me turn around and ask this to you as a question. Do you guys feel like you sort of understand what this project is asking you to do? Do you kind of feel a bit comfortable with what you're being asked to do with this? Let me actually just take 5 minutes to kind of just walk through all these things. So we're going to ask you to load the data set and display the first few rows of the data. I'm hoping, you're feeling pretty obvious about that. Pull up info on the data and each type of data fields. Will any of these be problematic feeding into your model? Okay. Again, based on our conversation about pulling that info thing, looking at your floats, ints, objects, right? Where do you kind of see some issue might be? Then we're going to ask you to drop some columns and display the summary statistics. Again, hopefully you guys are feeling, you know how to do that. We kind of walk through that. Here, instead of doing histograms, you're going to be asked to do box plots instead and describe a little bit about what you're seeing with that. Very easy to look that up. Just sort of Google. I think it's a NumPy or whatever, but just like box plot thing for it. Oh no, it's probably a matplot, whatever. Very easy. You just Google that, you'll find it. Then we're going to ask you to plot the average listing per neighborhood group. There's going to be a little tweak there. You're going to have to do a little bit. So this is just so you're aware, this data is looking at New York. And so New York has obviously boroughs, Manhattan, Brooklyn, Queens, right? So there's going to be sort of an intermediate step there. There's a function called group by that you're going to want to leverage to do that. Sort of allows you to cluster your data and then do some things around that. Then you're going to want to plot the map of the Airbnbs through New York. So again, that's exactly like the visualization we did with California. Then we want to look at some other kind of data filtering here. We want you to look at the average price of room types, where the availability is greater than 180 days, and the neighborhood group is Manhattan. So there, you're going to have to do a little filtering for the data. So you just create like an exclusion criteria where you're only pulling the data that's greater than 180 days and is only from Manhattan, and then you plot that. Okay, plot your correlation matrix. Again, completely just capture that you've already done. Preparing your data, augment the data with 2 features you think would be useful, exactly like what we went through, just creating a new column in your features, referencing the old columns, just doing that. Impute your data. Again, we walked through a few examples of how to impute your data already. So, you should be able to just kind of replicate that trivially. Okay, the only thing that's going to get you maybe a little bit iffy is that this pipeline thing, that's this mess of code here, which if you want to take a stab at it, awesome. If not, we'll cover that next week. And then you're going to do your breaking your data into says data as test. I don't know why there's 2 tests there, but whatever. 80% train, 20% test. It's literally just here. It's literally just, you're going to import this code here. You've already defined your labels, your data target. Then you have this line here, train test, target, target test. This line here, we'll go through this next week again. but this just kind of builds your training data, your testing data, your training labels, and your testing labels. And then you just call on your data, you call on your labels. This is the function that allows you to define the split. So in this case, it's a 70-30. If you want to do 80-20, you just change this value to be 0.2. And then random state, we'll talk about that next week, but you can just keep the default. Then that splits it. And then last but not least, pick a model of your choice and evaluate your model using MSE. And again, for that one, it's literally just this thing here. You import the regressionary model you want. There's some things here. We'll go through what these are, but it's essentially you just fit this into here. And then you can import your metrics, call in these metrics, report out the metrics. The code is basically like right there. You just copy and paste it. So as project one goes, how are you guys feeling about that? And oh, by the way, you got 2 weeks to do it. Is that like terrible, unbearable, brutal? Look good, pretty straightforward. Y'all vibing it? Anybody like not feeling good about it? Does this project use Anaconda or is it for other project? Yeah, so this is the Anaconda. So Anaconda is everything. So Anaconda will include Jupyter notebooks. Anaconda also includes like mainly like all of these libraries that you would use. So everything like sklearn, which is scikit-learn, which is for your learning models, NumPy, Matplotlib, Pandas, like all of these libraries that you're using for this, that's all in Anaconda. So Anaconda is just like one big compilation of data science related materials. So you just do that single install and it gives you all of this. But yeah, good question.
So you're saying we base Anaconda this should work with base Anaconda right out the box.
Yeah, you literally just install. Where's my little? You literally just go here, install this, and this will give you all the Python packages you need. This will give you your Jupyter notebooks. This will give you, again, Pandas, NumPy, Matplotlib, like all those Python libraries that we were calling, they're all there. And what's nice about it is that they're all compatible. You don't have to worry about like certain libraries being depreciated, certain things being non-compatible. You don't have to worry about those things. Like everything is just there and it just all works interchangeably. So that's why it's a really good, really powerful distribution. So again, you can, so there's a question in the chat about like running this on a cloud-based thing, like Jupyter Lab, Google Colab is another option, or running it locally. We're agnostic to that. Either way, if you just kind of want to just run it on a cloud-based thing, you can totally just take the notebook, upload it, and run it on a cloud-based solution. There's no objection to that. If you just don't want to deal with getting your local environment up and running, by all means. I like running it locally, but it's just all up to you. And again, we're not, ultimately we just want the outputs in a PDF form. So whatever works for you all. Okay, and then guys, do not forget, super, super important. Where's my next week? I am dead serious. You got to bring your A game for this. I want to see the best Zoom background. I don't want that generic Golden Gate Bridge Zoom thing. You got to up your games. Okay? Best Zoom background wins. And remember, I'm not the judge here. It's your peers. So you got to time this correctly. You gotta think it through. Get it optimized for your homies. Yeah. So any other questions? How do we sign up for that? Yeah. Okay. So for both secret Santa and the class directory, we will be sending out emails over the weekend. You'll get an announcement. They'll be posted on CCLE how to do both. I just have to kind of put both together, but you will get both of them this weekend. Okay. Anything else?
Hey, Lino, I just kind of had a question. What's the difference between projects and homework?
Oh, really good question. Okay, so the homework is going to be a written thing. So they'll give you questions and you'll sort of do a written submission. So again,
Okay,
homework questions could be like, give us 2 examples of imputation strategies you might use on your null values and discuss when it might be a good idea to use one or the other. That would be like an example homework question you might get.
Okay, cool. Thanks.
Yeah, absolutely. Okay, any other questions? Speak now or forever hold your peace. All right, thanks guys.